Look at your hand. Look at the screen. It feels permanent, doesn't it? It's not. You are standing in the middle of a slow-motion explosion that's been running for 13.8 billion years. And explosions don't last forever. We used to think the cosmos was eternal. We were wrong. The universe is going to end. And thanks to brand new data, the ending we were told might not be true after all. But to get there, we have to look at 4 ways the universe might cease to be, including one that could happen before I even finish this sentence. To understand the end, we have to briefly look at the stage. The fate of the cosmos is not a random roll of the dice. For a long time, cosmologists thought the fate of the universe was mostly a geometry problem. How much stuff is in it, and how strongly that mass bends space-time. That idea is captured by a number called omega. This is the ratio of the actual density of the universe to the critical density required to halt its expansion. Think of omega as a cosmic benchmark. If omega is greater than 1, there is enough mass energy to make space positively curved. If omega is less than 1, space is negatively curved. And for decades, this looked like the master key to the ending. Too much density and the universe might eventually collapse. Too little and it expands forever. And then the story changed. Our best measurements show the universe is very nearly flat. Omega is extremely close to 1. That tells us something profound about the geometry of space. But geometry alone no longer tells us how the story ends. Because the universe is not just matter and gravity. It is dominated by something else, something that pushes space apart. Dark energy. This brings us to the scenario that you've most likely heard about, the Big Freeze. We also call this the heat death of the universe. It is not an explosion. It is a slow, agonizing maximization of entropy, a transition from light and complexity to cold, uniform nothingness. Dark energy accounts for roughly 70% of the universe. It acts as a repulsive force pushing space apart. In the standard view, it remains constant. It simply continues to push. If this holds true, the future is a long, slow slide into the dark toward maximum entropy. It's not an event, it's a process. Astronomers divide this timeline into eras. We are currently in the stelliferous era, the age of stars. But we are already in the autumn of this era. The peak of star formation is behind us. The largest stars will detonate. Eventually, even the final torchbearers, the red dwarfs, will flicker out. The universe will go optically dark. Welcome to the degenerate era. We aren't talking about moral decay or a cosmic midlife crisis. In physics, this means we're looking at a graveyard of white dwarfs, neutron stars, and black holes. Eventually, even the black holes will evaporate via Hawking radiation. What's left is the dark era, a soup of photons and neutrinos stretched so thin they never interact. The universe ends with a big whimper. But it assumes that dark energy is constant. What if it isn't? This is where the new data changes the story, and we get to the big rip. The 2024 and 2025 reports from DESI, the Dark Energy Spectroscopic Instrument, hinted at something unexpected. They suggested that dark energy might be evolving. The crucial variable here is W, the dark energy equation of state. This basically is just the stiffness of dark energy. It is the ratio of its pressure to its energy density. If W equals -1, we get the heat death. But if W drops lower, say to -1.1 or -1.5, we enter the realm of phantom energy. In this scenario, dark energy does not stay constant. It gets denser as the universe expands. The expansion accelerates so fast it overcomes the forces holding matter together. In one commonly cited Big Rip model, the timeline looks something like this. 60 million years before the end, gravity is overwhelmed. The Milky Way dissolves. Stars drift into the void. 3 months before the end, the expansion of space between the Earth and the Sun becomes stronger than the Sun's gravity. Earth is ripped from its orbit. 30 minutes before the end, the expansion overcomes the gravity of the planet itself. The Earth explodes. The crust and core pulled apart by the expansion of space itself. In the final fraction of a second, the phantom energy overwhelms the electromagnetic and nuclear forces. Atoms are torn apart. Space-time tears. But what if the data means dark energy is weakening? What if the ball rolls backward? This is still speculative, but recent data hints at the fact that dark energy might be weakening. If this happens, the expansion halts, and the cosmic pendulum swings back. The universe could stop expanding and reverse. This is the big crunch. But don't mistake this for a simple rewind. Thermodynamics does not run backward. Entropy continues to increase. As the universe contracts, the light from every star that has ever shone is compressed. The night sky shifts from red to blue to ultraviolet. The sky becomes bright, then hot, then blinding. Eventually, the ambient temperature of space exceeds the surface temperature of stars. The universe ends in a fiery cosmic incinerator. The crunch, the rip, the freeze. These all take billions of years, but there is one scenario that requires no warning at all. It could happen tomorrow. And this is the wild card. The crisis here isn't gravity, it's quantum stability. This is vacuum decay. This threat comes from the Higgs field, the energy field that gives particles their mass. We believe the Higgs field is currently in a metastable state. Think of it like a ball resting on a small dip on a mountainside. It seems stable, it isn't moving. This is a false vacuum. But farther down the mountain, there's a deeper valley, the true vacuum. According to quantum mechanics, it is possible for the field to tunnel through the ridge and drop into that lower valley. If this happens at any point in the universe, it creates a bubble of true vacuum. Inside this bubble, the laws of physics are rewritten. The constants of nature change. Chemistry becomes impossible. Because this bubble is energetically favorable, it expands at the speed of light. You could never see it coming. No warning, no last message. If the bubble reaches us, reality is simply rewritten. But what if the end isn't actually the end? What if the death of the universe is just the ignition sequence for the next one? Sir Roger Penrose, a Nobel laureate and one of the great minds of mathematical physics, proposed an alternative. He calls it conformal cyclic cosmology. Penrose looked at the extreme, highly ordered low-entropy state of the Big Bang and asked, why was it so perfect? Remember the heat death of the universe? Trillions of years from now, when the black holes evaporate, the universe will contain only massless particles like photons. To a photon, time and distance do not exist. The size of the universe is irrelevant. Penrose argues that the infinitely expanded cold end of one universe is mathematically identical to the incredibly hot, dense beginning of a Big Bang. He suggests that our Big Bang was not the beginning. It was merely the transition, the crossover from the previous eon, and our heat death will be the Big Bang of the next. And we might already have the evidence. Collisions of supermassive black holes in the previous eon would result in massive gravitational waves. These waves could pass through the transition and manifest as concentric rings of slightly different temperature in our current cosmic microwave background. Penrose calls them Hawking points, anomalous rings in the cosmic microwave background that might be gravitational echoes of supermassive black hole collisions from the universe before ours. We might literally be seeing the ghosts of a dead universe in our sky. So, will we freeze, burn, rip, or reset? The end of our universe is a heavy concept. Our time is borrowed. But there is perhaps a profound beauty in this. We exist in the infinitesimally narrow window where the universe can wake up, look around, and comprehend its own mortality. We are the cosmos thinking about itself. We are the brief flash of consciousness that can appreciate the stars before they go out. The end is inevitable. But the story is what we make of it while we're here. Which theory do you think is most likely right now? Heat death, big rip, big crunch, vacuum decay, or something else? Let me know down in the comments. If you want to keep exploring the darkest and most fascinating corners of reality, please consider subscribing. Thanks for watching, be kind to each other, and take care.